Hello students, now the question number 61. Question number 61, what the question is saying that, so the molar conductivity of 0.05 molar conductivity of 0.05 molar, this molarity of solution of weak monobasic acid is 90. The data is what the given. So given data we always have to write, then only we'll get to know what the question they're asking, what they given. So molar conductance they given as 90 Simon centimeter square mole inverse they have given. Now what they're asking degree of dissociation, that is alpha is equal to lambda m by lambda naught m. This is the most important formula. Students will definitely ignore this one. Why? Because so they think that the question they will not ask this much of easy question. That is what the NTA will ask the question wherever we lack the question. Now, what and all that are given? See, we have the lambda m they given. Lambda naught m also they have given, but they have given indirectly. So Corla's law, what is still in the Corla's law? Suppose if I want to get the KCl solution molar conductance, what I will do? Lambda naught m KCl, that is equal to lambda naught K plus lambda naught Cl minus. Same like this, add these two values. Which two values? No, 349 for a cation, 50 for anion. So add together. So 349.6 plus and 50.4. Now after adding this, how much we're getting? So let me do 349.6 plus 50.4. 50.4. So we're getting 349.6 plus 50.4. We're getting 400 will be the values coming. We're getting 400 lambda naught. That is C mine centimeter square mole inverse. Now substitute here lambda. How much they given? 90. By lambda naught, how much you got? 400. 0, 0 cancel. So now, so 9 by 40 we are getting 9 by 40 we are getting 0.00, sorry, 0.225. 0.225 will be the degree of dissociation. That is option C is I can able to see the in the option. Option C. See the guys options are very nearby. So select the answer very carefully. Okay. So now we'll go to the next question number 62. 62 question, what they're telling that 62 question. So they given two statements. The two statements, first statement, what is telling that statement one, a hypothetical diatomic molecule with bond order 0 is quite stable. Guys, it is a foolish question. Students, they will make the fool, right? How they make the fool? See, we know that any compound or any molecule having the present means it is stable, any molecule, the molecule should have the bond. Suppose let me take H2 molecule, O2 molecule, N2 molecule. So in all the cases molecules, there is a at least one bond will be there. One bond will be present like this, like this. So here bond order zero represent that there is no bond. If there is no bond, then how the molecule exists? If the molecule exists also, it is not stable, right? So the first statement is completely wrong. First statement is completely wrong, right? Now come to the second statement. So statement one is false. Statement two what happen? As bond order increases, the bond length will be decreases. So bond order, bond order inversely proportional to the bond length. Bond length. Now this is the relation we have to see in this question. So what they given here? They're telling that bond order increasing as well as bond length decreasing. That is a false statement. Now I will give the one small trick to find out the bond order as well as bond length. So here bond order as NCERT formula what we have. So as per NCERT, inside formula. So bond order is equal to, so number of bonding electrons minus anti-bonding electrons by 2. This one we can able to use the bond order. There is one more formula I will give you to use the up to 20 electrons. Now, if the electrons, if the number of electrons is between between 8 to 14, then bond order is equal to what we have. So bond order is equal to, so here n minus 8 by 2. This is a bond order. Now if the electrons, if the electrons, if if the electrons between 15 to 20, then bond order is equal to 20 minus n by 20 minus n by 2. So this very, very important formulas. Please note down. Very, very useful for your numericals of chemical bonding, right? So case of bond order. So the in this question, what is the answer? Second statement is false. First statement is false. So the option we have only two. So thank you guys. Hello students, now the question number 63. 63 question what they're asking, out of the following complex compound, which of the compound will be having the minimum conductance in a solution? So what is the key concept involved in this question? The key concept is key concept involved in this question is, so conductance is proportional to the number of ions, number of ions present, right? More is the ions, more is the conductance, right? Now, suppose if I try to dissociate this compound, so here outside of the complex, outside of the, this is called as a coordination sphere. This is the coordination sphere. Outside of the coordination sphere only, the ions which are present, they only will undergo ionization. If I try to dissociate this one, this becomes as it is only. It will not dissociate as further. Cl3. So here number of ions will be 0. Second case also no ions are there. Second case also number of ions are 0. Third case what happen? If it dissociate, it will come like this. So here plus 3 and 3Cl minus. So you can see here 3 ions plus 1 ion. Total a number of ions will be 4 here. Now in this case, last case what happen? If I dissociate CO, NH3, 5, Cl here plus 1 and Cl minus will come. So here this 1 ion, this total 1 ion. So N is equal to 2 here. So what is the condition we have? More is the number of ions, more is the conductance. So the question is, the answer is clearly appearing, no? The conductance is proportional to the number of ions. So option. So minimum number of ions what we have two options are there. One will be option 1 will come, option 2 will come. Both are right answer guys. Thank you guys.